Welcome everyone to another interesting DSA problem which is titled as linked list cycle part 1. So there will be a part 2 also that will be explained in another video. So let's try to understand what is the problem statement. So you will be given a linked list and whatever mentioned in this box is nothing but how to construct a node and the node which pointing in that linked list, and a head is also given. What you are supposed to find is that you have to check whether the linked list have cycle in it. Cycle means if you start from a point and if you move forward, at some point if it's coming back to any of these nodes which is already has like overcome or passed, that means there is a cyclic structure. That's because this particular pointer is pointing to one of the nodes which we already have come across. We have to check does this features as existing in the linked list or not. Instead of this 4 pointing to this 2, if it was pointing somewhere else or it is not pointing anywhere, this would have been like a normal linked list. So if it's a if it has cyclic feature, we have to return and check and return true. If it does not have a cyclic feature, that means false, that factor. How can we do that? What we can do is that similar to what we have already seen in linked list, we can use the slow and fast pointers. So initially we can fix slow and fast pointers at the head. Then we can move slow and fast pointers in a relatively varying speed. For example, slow jumps one step, fast jumps 2 steps. So basically fast will move ahead, slow will go behind. So what is going to happen, since fast is relatively jumping more steps than 2, so initially the slow will be here, fast will be here. In the next step the slow will be here and fast would be here because it's cyclic feature, and next step slow will be here and fast will be also here. So you can see at some point, even though the fast has moved forward than the slow, it does like overlap. So we have to check this condition. We can try to evolve like slow and fast pointer, and at the end if both are converging at some point, that means it has cyclic feature. And if it does not have a cyclic feature, the fast pointer will terminate at some point. So in that case we don't need to do that. The fast point or the fast dot next pointer, any of them will terminate at some point. That is the whole logic. So let's try to code it. Okay, yeah, and this is going to the class definition and all. Class solution, what is the method name inside it? Okay, method name is has cycle. So let's try to write the arguments by itself. The one is head, which is an optional list node. And what else is there? Nothing. We just need to return a true or false. So it's a boolean return. Okay, let's fix the slow pointer in the head and the fast pointer also at the head initially, and we are going to check while fast and fast dot next. Either one of them will also work, but in this case we can write like this. Okay, in that case we can advance slow to slow dot next and fast to fast dot next. Why we have returned slow, fast and fast dot next is because if the fast dot next doesn't like existing this assignment operators, we cannot do that. That's why we checking whether fast exists, then fast dot exist checking, because this upgradation is going to happen inside. Okay, and inside this thing we have to check if slow pointer equal to the fast. That means there is a cyclic feature. In that case we need to return true. If that is not the case, the fast pointer would terminate at some point and it is not ever going to overlap. So in that case, as a default return condition, we can give return false. So what is the time complexity? Time complexity we are just going through once. Most probably that would be time complexity with order of n. And space complexity we are not utilizing anything to store or anything, just pointers has been assigned at many different points. So space complexity is order of 1. And I hope you understood this particular problem, and thank you for listening.